Pleasure to be here at such a popular workshop. Oh yeah, my name is Ruth Silverman. I am a learning services coordinator at the Student Learning Commons in the library, and I've been there now for 16 years. Try to learn as much as I can about quantitative strategies, but I always want to partner with a real expert.
So I, as it says on here, I am Dr. Sarah Johnson. I am what's called a university lecturer in the physics department, which means I'm teaching faculty. I have been at SFU for 18 years, but I've been teaching first year physics for about 30 years, since I got my PhD in 1993, so a long time ago. Anyway, and so we thought this would be really valuable, so I'm really glad so many of you were able to come. And we'll get started.
Yeah, and we definitely want to acknowledge that we're here on Coast Salish land, the land of the Musqueam, the two Patsy and Coquitlam people. The land means an awful lot to me. I did my master's here. I feel like it gave me probably a third or fourth chance in life doing my master's here, and was thrilled to be able to come and work here. So these are the big general areas we're going to cover. And as you can see, there's a lot of sub areas as well. The transition to university quantitative exams. And just for the people in the room, can you raise your hand as to whether this is the first time you'll be taking a university level quantitative? Yeah, so there's a number of people transitioning, probably some on Zoom as well. Then, several factors in how to prepare before the exam, and also some factors in when you're actually sitting there, what are some useful strategies for writing the exam, and maybe some that aren't as useful. Okay, so transition.
All right. So just to talk a little bit about transitioning to university quantitative exams, basically some of the differences you might encounter with the exams you run into here at university versus what you experienced in high school. So typically there are going to be fewer tests or exams that will each be worth more points. Sometimes they're quite a lot of points. Typically, if you add up all the points for all the exams in a science or math class, it'll be way more than 50%. You may have noticed that. Typically, for quantitative exams, memorization does not work. That's not a helpful thing. In fact, for example, with physics exams, you're often given a formula sheet, right? So basically, it's important to be familiar with formulas, but you don't necessarily have to know all the little details. There are typically no makeup exams. That varies a little bit by instructor, and also extensions are quite rare. Okay, so keep that in mind. One thing some instructors will do if you miss an exam is they'll move those points to the other exam and the final exam, for example, rather than give a makeup. So I'll go around this way this time. You'll often run into new problems on tests. So problems you haven't seen before, they'll be on the same topics and they'll be similar to things you've probably seen on quizzes or homework, but they won't necessarily be identical, or they won't be the same problems with different numbers. There'll be a whole new question. So consistent work is really a necessity, okay? What we mean by that is starting from day one. I know we're already week 3. Are we week 3 now? But you can still catch up. But basically, working every week, doing a little bit of work every day is really important. If anyone asks me my #1 recommendation for university students, especially first year university students, is to go to class every single time. All right. There are instructors getting paid a reasonable amount of money, maybe not a lot, but we're getting paid to teach you guys, to help you learn, all right? And, you're going to get a better insight on what's going to be on the exam if you listen to your instructor, the person who's going to make up the exam, right? The problems will typically require more than plug and chug, too. There's definitely going to be thinking involved in a lot of the problems.
All right, so on to preparation, and basically, that's kind of it, but there's other things to say about it. And first we'll start from the learning strategist perspective and also get into the quantitative specific. So we want you to keep your healthy habits up. I mean, often when it's a very busy time, that's when you let your nutrition go, you sacrifice sleep, you let your exercise go. You're like, I don't have time to exercise. But I'm going to suggest that these things are even more important during a busy and stressful exam time than they normally are. Okay. So exercise is, if you are in the habit of exercise, it's one of the prime ways where you re-energize yourself and you get rid of your stress. So why would you give up exercise when it's going to be especially stressful, you know, and you're going to need your energy? So it's something that's worth making time for. You might want to, you know, if you have to study more than usual, you might want to reduce time spent on other things like, you know, socializing maybe. I mean, although, you know, so you do need some social support, obviously, or television or whatever. Then also caffeine, you know, so yeah, I was just talking to some students yesterday and they're like, oh, I think I'm going to go get a Red Bull because I have a lot of studying to do. And, you know, in the moment, it might seem like a good idea. If you are at all prone to having anxiety and feeling very anxious when preparing for tests or writing tests, it's probably one of the worst things you can do, because caffeine and sugar are substances that increase anxiety. Like, they will increase alertness, but it'll extend to really increasing your anxiety. There are other substances such as nicotine, cannabis, which surprises people because they think they're going to mellow out with cannabis, but actually it does increase levels of anxiety. So there are a number of substances to avoid as well when you're in this situation. And Sarah's going to talk about a bit about sleep.
Right. So quickly to connect to caffeine, I know I am like very sensitive to caffeine in the afternoon. It really disrupts my sleep cycles, and sleep is so important, especially for quantitative exams where you're trying to solve problems, you're trying to work out calculations. Okay. You're better off like the night before exam, even if you haven't had a chance to study all you wanted to, you're better off sleeping, spending those extra couple of hours sleeping than studying, because you need an awake brain to handle a quantitative exam. And I know a lot of our math exams are at 8:30 in the morning, which makes it even harder. Okay, right? So it's really important, right, to get as much sleep as you can. All right, so this is just another thing about exam preparation is to review previous feedback. So this is actual problems, little pieces of problems that students submitted via what's called CrowdMark, which is the software we use here to enable the teaching assistants and your instructors to mark written assignments. And what you can see is that they have gone through and told you what was right, what was wrong, and even written comments. So I highly recommend when you get a homework back, don't just look at the number, go and actually look at what you lost points for. Okay, because it might be something you're surprising. All right, you know, so you can see that in both of these cases, these are kind of short comments, but in this case, there's an even much longer comment explaining what you did wrong. You didn't substitute numerical values. So it gives you an idea of what they're looking for, okay, and the kinds of things to make sure you don't do wrong when you do a similar problem on an exam.
All right, so we're going to turn it over to you, and that includes the people on Zoom who can type in the chat. Does anybody want to suggest what they think would be an effective study strategy for quantitative exams? Like, what do you do that works? What do you plan to do differently? Yes, thank you.
Doing the practice problem, but like imitating a test setting, so not using your phone or anything to solve it. Mm-hmm. That's really useful, actually.
Yeah. So I said, like, there's practice is optimal, but there's better practice and there's worse practice, right? So trying to practice solving it from memory, or just maybe if you were allowed a couple of formulas, having those as if you were going to be writing an exam, and also maybe under time limited conditions. Yeah. Okay, Colin, are there any on Zoom?
Going to office hours after practice questions.
Yeah, absolutely. You know, and maybe trying to get an explanation if there's some that you can't solve. Actually, my boss, it's not my kids, so it's my boss's kids, so I can brag. My boss's kid went through the actuarial science program here. And what he would do is, I think especially for classes where there wasn't an actual math workshop, he would sit outside in the hallway when his professor was having office hours and work on his problems there, so that if he got stuck, he could just pop in very easily. Right?
Yeah, and that's a good strategy. You can also do, I mean, I run my extra help hours, that's what I call them, sometimes in the classroom, and some of your instructors might do that. So you can actually go and sit there and stay there. And similar, you can do something similar with the science and math academic support. You can actually go and sit in that room and work on your homework and then ask that person questions when you get stuck.
Yeah. Any other suggestions, either in the room or on Zoom? Colin?
Not just rewriting your notes, but instead doing practice problems and learning from your mistakes.
Yeah, I mean, there are ways that students can, you know, kind of delude themselves to think they're doing something useful to prepare for the exam. And especially in quantitatives, it's not just kind of mindlessly rewriting notes. Yeah, practicing is definitely a much better way to spend your time. Also, would you say reading the textbook is not necessarily as useful, the rereading? Because I've
well, rereading is not as useful.
Yeah.
One thing I would say with the textbook, it depends a little bit on how your instructor uses the textbook, but if there's something that they explained in class and you did not understand their explanation, it might be worth looking in the textbook under the same section, because people put a lot of effort into writing these textbooks to make them understandable. I mean, I helped write a textbook, and I know we tried really hard. And so you might understand the textbook explanation better than your instructors.
Yeah. So they're useful, but, you know, rather than spending your time rereading, you know, like you might in other disciplines, problem solving. Aiden, did you have something to say?
Just want to share something I heard about office hours. And it's actually a student who shared this with me. They attended physics office hour this morning, and there's so many students there. Prof actually moved to a larger room, but the questions that were asked were actually similar with the other students who are there. So you never know, for anyone who has, you know, maybe a little bit of intimidation towards going to an office hour, feel like it's a little bit scary or not sure how to do things, you can often go and there's other students there. And you never know what questions are being asked, and you're welcome to stay and listen, right? And often they're the same questions you're thinking of anyways. So don't feel intimidated about going to an office hour and not knowing what to say or exactly what's the right question to ask. You can learn just by listening too.
Yeah, and absolutely. And I run Zoom office hours, and that's totally fine. People will just log into the Zoom session just to listen, and I have no problem with that. If you want to just listen, that's great.
Okay, is there maybe one more comment?
We probably should move on. I'm worried we're going to run out of time.
Okay.
Yeah. So
let's do that then. So this is just in general, and you can apply this to any course that you're taking, not just quantitative. There was this study that was done in 2013. And for the last 10 years, it's just been absolutely pivotal in the field of learning strategies. They reviewed 20 years of research of 10 different study strategies. And it's called a meta-analysis, where they just sort of crunch a bunch of other research together. And so this was at all levels of education, from elementary up to grad school, all disciplines, you know, the science, the applied science, the business, the arts, all of it. And they found that only 2 of the 10 study strategies were universally applicable, no matter what you were studying and at what level. And one is distributed practice, which is kind of the opposite of cramming, okay? So it's basically all the way through the term, even when an exam isn't coming up, trying to like review your notes, reviewing from memory, trying to remember as much as you can, doing practice questions, like basically all the way through. And then for the actual exam study period, having a longer period of time with short, frequent study sessions. There's a lot of advantages. It gives you a chance of forgetting the material and having to reconstruct it. It gives you like less stress, less sleep deprivation, and you're less likely to run out of time, because I think a lot of the time students will underestimate how long it takes to prepare for an exam if they cram. So that is one of the really important study strategies for anything. And then of course the other one is practicing. And you might think, I mean, it's kind of obvious in quantitative, but if you have a multiple choice test in an arts course, if you have an essay test, practicing with questions that are similar is useful no matter what. You might not want to write an entire essay like several times while you're practicing. It might take too long, but even just making an outline of how you would go about answering an essay question. And then this other image is having a study group. Having a study group can be very useful, and especially in these quantitative classes, like where maybe somebody encounters a difficult problem and they can get a classmate to explain it, or maybe somebody solves a difficult problem and they give it to all the other people in their study group to say if they can solve it too.
All right, this is me, right? Yeah. Okay, so within that practice, it doesn't matter how you practice too. So the most important thing is that you have to spend some time working problems yourself. Okay, actually working the problems. Okay, and this goes along with the second problem, that you really need to struggle with the material for a while to learn it. All right, and we'll talk more in depth about struggling in a minute, but that self-struggling, my friend calls struggling the sweat of learning, basically. Okay, so it's like you can't just watch somebody work out, you have to work out yourself, right? Watching someone else work out, not so helpful. Okay, sometimes it's useful to go through and explain to yourself what's going on in a problem and what you would do for each step, okay, or explain to yourself a complicated concept. Back to study groups, explaining to friends in a study group can be really, really useful. There's lots of evidence that basically that when you're teaching, in the process of teaching, you're learning. Okay, so anytime you have to explain something to somebody else, basically that's the test of whether you really know it. Because if you know it well, you can explain it to your friend. If you don't know it that well, like you'll discover when you try to explain, like, oh, there's parts of this I don't really know. Again, memorizing doesn't work for quantitative exams. Rewriting your notes in quantitative exams, not really helpful. And especially watching someone else solve problems, not as helpful. It might be helpful to help you figure out how to do it the first time. But after that, you really got to do them yourself. Okay. Yeah.
What happens if you don't know the material well enough to make practice problems and there are no problems applied by the professor or the textbook?
All right, so that's it's really unlikely that there aren't any in the textbook, because every textbook that I've run into, at least nowadays, has sample problems and practice conceptual problems. I mean, you can go searching online if you have to be a little careful to make sure that the problems are at the right level. They use the same variables and things like that. I would really go back to your instructor and ask them to point you towards a good source of practice questions. I mean, when I ran my first year physics, I will add a bunch of practice questions to the online homework system for students to practice for the upcoming exams. So I don't think it's unreasonable to go and ask your instructor, can you please provide some sample problems, practice problems, or point me to a source. So when you are practice testing, so this is similar to what you were saying with do it without your phone. Another nice trick. So this is the actual order of topics for a class I teach, and this is first year calculus-based physics, second semester. This is the order the topics come in week by week, is to scramble the order. Because when you get them on an exam, they're not necessarily going to be in the order that they're in, right? That you learned them in. They could be in some other order. And that helps you recognize the problems and what concepts apply, sort of independent of the order that you're seeing them in.
Struggling, strangely enough, is me. Yeah, I actually was talking to another physics instructor from another institution, and he was saying that when he was in first year, he would just do the easy problems. Like, he was talking about all the things he did wrong. He said he would, say he'd do a problem set, he'd get 18 out of 20, and then he'd be like, oh yeah, well, that's good enough. I don't have to worry about these other ones. It tends to be the more difficult ones that would show up on a test, for one thing. So there are a few reasons why you need to practice struggling through the difficult problems. And the fact that they might appear on the test and you have to know them is only one of them. One of it is really that you need to get comfortable with that really horrible feeling that comes when you're trying to solve a problem and you don't know how to do it. Because if all you do are the easy questions and then you get to the exam and there's something really challenging and it's worth 25% of your exam, that is not only going to be hard for you to get those points, but I almost feel the symptoms of tension in my stomach just talking about it, right? It's going to freak you out physically and mentally. And if you get really freaked out while you're writing an exam, the other 75% of the exam that, that would normally be hard for you may suddenly become really hard for you because you're distracted and anxious and your brain is kind of scattered. And that's when people sometimes blank out or freeze. So, you need to move through anxiety that comes with not being able to solve problems in a safe situation where it's not counting for grades, when you can go and seek help and get a little hint to move you to the next level, when you have unlimited time, although, realistically, you always have limited time, but the time frame is a little bit longer. Like you're kind of training yourself to be able to handle those kinds of problems on an exam, because they will come. Okay, so, right? Yeah, I think I can talk to it anyhow. I kind of lost my place in my notes, but yeah. So we talked about practice testing being, really important. And it's especially important, to do like Sarah said, mixed problem sets, but sets that don't have like headings on them that give away what type of problem it is. Because there are no headings on these exams, right? And the problems are all mixed up. And sometimes one problem could be from, various parts of the course altogether. So if you're in math, the good news is that there's a bunch of math exams, prior ones, available online if you scan the QR code. Other departments, they do various things. I understand in some departments, getting them from the student union is possible. Does anyone have a tip for getting an exam from another department? And sometimes professors will just make them available in their Canvas or something.
Right, and if a professor or instructor doesn't make practice exam available, it's always okay to ask if they will. I mean, some don't like to, but my experience, most people will. Okay.
Mm-hmm. And you also don't want to just like go through one or two practice exams and be like, I'm good, because you have to remember that your exam is going to be different, right? I mean,
especially if they share the exam with you. If they share the exam, they're not going to give you that exam. Okay, it's going to be different. So like, it's good to look at practice exams, but I sometimes see students spend too much time on the one practice exam I post, and they don't look at everything else available, all the homework that was assigned, all the tutorial exercises that were assigned. You should look at everything that your instructor has assigned up to that exam point is fair game to draw from to ask questions on the exam. Okay, so there's lots of different things to look at.
Yeah, but the level of the questions And the way they're written
Yeah.
is also going to be probably pretty similar. You know.
Okay, so like we were saying, when you especially want to practice these difficult problems, and just to give you an example of some of the types of different difficult problems. So there are some with what we call hidden knowns, which means there are quantities you need to solve the problem. They're not given to you because basically you're expected to know them already. Things like number of hours in a day, or maybe even something like how many meters in a kilometer. There's some basic things, or I often won't give students the area of a circle. That's something I expect them to know, some kind of basic math and, you know, and sort of units kind of things. Okay, missing variables. So this is where normally there's a variable you would need to solve the question and it's not there. And that's probably because it's what we call a ratio problem, where you're dividing one thing by another and that variable would cancel out. So you don't actually need it. Red herrings. Okay, I tend not to do red herrings on exams, but some instructors do, and that's where they give you a piece of information you do not need to solve the problem. Okay, it's kind of mean. Okay, some people will do that. Okay, so they'll give you an extra piece of information. Sometimes if you've got a really difficult problem and you actually happen to have a solution to it when you're practicing, this works for practicing, is to work backwards, okay, from the solution and try and figure out how they got it. Definitely practice solving problems with only letter variables, okay, without numbers, all right, because they're not, the problems are not always going to have numbers in them. And then there are different types of multi-part questions, quantitative questions. Sometimes they ask you, it's the same concept over and over. They just ask you to calculate the same thing 3 times with different values. Sometimes they'll ask you to calculate one quantity and then a second quantity where you have to use the first answer to get the second one. Those can be a bit trickier. Typically, you will get partial credit if you got the first part wrong and you use that number in the second. Okay, and then the hardest ones are probably the ones where you have to solve sets of simultaneous equations. So this is like when you have 2 equations and 2 unknowns, or 3 equations and 3 unknowns. Remember all that stuff from math, right? Those also show up in physics and chemistry and places like that too. Okay, so you might think, oh my goodness, I don't have everything I need to solve this problem. My advice is to go ahead and write down all the relevant formulas, what you know you would do, and you might suddenly see, oh, I have 2 equations that both have those 2 variables I need to solve for. And then you're going to have to solve your simultaneous equations.
Yeah, so the QR code there is linking to an SLC handout that has a little tiny bit more of an explanation of these. And you will be provided with you'll get an email after if you're registered, you'll get resources such as that and the slides.
Yeah, there's SLC has lots of great stuff online.
Thank you. Yeah, and also, you know, these are the kinds of problems to seek out, you know, if they're not obvious for you, to make up for each other if you were in a study group.
I think we had a couple of examples of these.
Yes.
Click
Yeah.
for a second.
There you go.
So, so the first one is a missing variable problem. So this is Moksha ran a race at a speed of 5 meters per second. It took him 8 seconds to finish. If Grace runs at a speed of 5.5 meters per second, it's physics, right? How long will it take her to finish the same race? So what's missing there?
The time.
Well, that's what you're looking for. So the time for Grace is missing. What else is missing? The distance. We don't have the distance of the race. Turns out you don't actually need the distance of the race because the distance is the same for both of them. Okay, so this is a missing variable, right? You might think, how can I solve this if I don't have the distance of the race? But it turns out it doesn't matter, right? You know, distance is velocity times time. You can set those 2 equal, right? The 2 velocity times time. And then the second one, an example of sort of hidden variables, right? So estimate the speed of the Earth orbiting the sun. Okay, how fast is the Earth moving when it goes around the sun? Okay, you can go to Google, okay, and you can look up everything you would need, plus a couple of physics equations to figure this out, okay, because speed, as we know, is distance over time, okay? The distance is the circumference of a circle, right? So that's something you're like, okay, I know it's a circular path. Okay, I know the radius is the Earth-Sun distance. Okay, because we're talking about the Earth in a big circle around the sun. I know the time it takes to go around once is a year, right? So those are all things you can look up. Okay, so this would be like if you had this for homework. For an exam, they would have to give you these values on a formula sheet. I don't think anyone would expect you to memorize, at least not this one. They might expect you to know that one. Right? Okay. All right, and then you get it. Turns out the Earth's going actually really fast. 30,000 meters per second. Pretty darn fast. Can't feel it, right? Okay, but we're going pretty fast. So that will give you an idea of a couple types of problems. All right, so formula sheets. I think this was me. Okay, so in some cases you will get formula sheets or you'll be asked to construct your own. Okay, so if you want to construct your own, which some instructors let you do, make sure to include the important formulas you use a lot. Label the sections of your sheet with the concepts and the topics each formula apply to so that you can find them easily. Use the same variables that you used in class. Don't use the variables you used in high school. I see this a lot in physics. People are still using the variables they used in high school. Please switch over. Okay, it's going to make the TA's life much easier when they're marking your exam if you're using the variables that your instructor's using in class, because they'll be consistent about using those. Write large enough, so don't cram your formula sheet with tiny, tiny, tiny little writing to get every single thing in, because then you'll never be able to find things. And with the writing's really small, it'll be hard to find things. Write hints to yourself next to tricky things. Okay, and proofread it carefully. Okay, make sure you didn't make any mistakes. And then that's how you make your own. And now, how do you use it in an exam or before an exam? Practice solving homework problems, right? Just using the formula sheet so that you know where to find things on it. Okay, make sure you know what all the variables mean. Okay, this is also useful if you don't have a formula sheet and you just you're working on memorizing various things for math. Okay, make sure you know what all the variables mean. Okay, and be careful because sometimes the same variable gets used more than once. Okay, like sometimes the letter L will be length, or it might be, there's something called inductance in physics, which is also L. There are other things that are L, luminosity sometimes is L. Okay, so be careful. If you're given a formula, you know what all those letters mean. And then when you are taking the test or exam, I think it's always a good idea if you can to take it off the back of your test and put it next to you so that you can see it easily while you're taking your test.
You know, when you were talking to me about this, you were saying that if the professor doesn't hand out the formula sheet in advance, students should ask for it because it's really, you know, useful to practice using that formula sheet while solving problems rather than seeing it for the first time when you're in the actual exam.
Absolutely. And most people will be willing to do that. Sometimes I forget, and then a student will ask me, sometimes even like week 2, can I have the formula sheet because I want to use it to do homework? And that's fine because usually you've got old versions of it floating around. So and that can be really helpful.
So now you've got an example of a formula sheet.
Oh, so this is just an example from Physics 101. I think some of you guys are taking this was my Physics 101, but just to give you an idea of what it looks like, when I make formula sheets, I do actually label the topics that those formulas go with. Okay, but that's kind of a typical. So you can see you're not going to get everything. You're going to get what the instructor thinks are the primary important basic formulas, okay? You're not going to get things solved. You're just going to get the formulas. And maybe some variables. Yeah.
Can we access that anymore? Like your formula sheets?
I can give it to you if you want. I can give you some formula sheets if you want to hand out to people. Sure. Yeah.
We're gonna get the slides for this presentation.
Yeah, she will get the slides. But if you want to see the rest of it, I'm happy to share some of my formula sheets.
Yeah, we have to make our own, so I'm scared I'll miss something.
Oh, all right. Yeah, no, I'm happy to share my formula sheets. All right, where are we? Writing, quantitative exams. All right, so now we're up to the writing part. Are we going all the way to 12:30 or 12:20?
Ideally 12:20.
Okay.
With a bit of wiggle room.
Is this you or me?
Yeah, this is me.
This is you.
Because this is just kind of general stuff. And, you know, again, these are things that would pretty much work no matter what type of exam you're writing. So if there's things that you have, you know, remembered and you're not going to have it on a sheet or something and you're afraid that you're going to forget it, as soon as you were told that you can start writing. You can just write that down before you start, looking at the questions or answering questions. Just dump it out of your brain so you know you have it. Then you want to skim the whole exam and make a plan for like the order in which you're going to be answering them, and also the amount of time you're going to be spending per point and like per question. You get a ballpark. If the question's worth 10 marks, how much time are you going to be spending on that? And go, identify easier questions to do first. So I always used to just jump around. My exam booklet would be like question 4, question 8, question 2, jumping around, question 4A, and then like quite some time later, question 4B. So makes it a little harder to mark. But, as you solve the easy ones, you're not leaving any marks you could get on the table. Because you don't want to run out of time on something that you could solve. As well, if we're talking from an emotional standpoint, as you solve the easier ones, you're going to build the confidence to solve the more, harder ones. Like you're not going to get an anxiety attack in the first 5 minutes of the exam if you're working on the easy ones. And also if you've skimmed, then you kind of know what are some of the other ones that are coming up. And as you solve the easy ones, the back of your mind might work through how to get started on the other ones. Bring a highlighter. I think that that's a tip a lot of people don't necessarily do, or underline, and there's keywords. So if you're not really sure, if it's a big complicated word problem, you might want to highlight what you're solving for example, to keep that in sight. You want to highlight, like if you're somebody who drops a lot of negative signs, like definitely highlight negative signs as you work through. And if you have a section of the exam that says, answer 3 out of these 5, right when you're going through, highlight the ones you're going to answer. Commit to, identify it early so you don't have to bother reading over the other ones again, and commit to it and don't jump around. And that was one thing that I would do wrong. Like typically if you're supposed to answer 3, the first 2 would be like, obviously I'm going to answer these 2. And then for the last one, sometimes I would jump around starting an answer, and then going to another one. And it's like, no, that's a complete waste of time.
Okay.
Yeah.
All right, on to the next one. All right, so mixed format exams. So this is me, right? I think this is exams where you've got some multiple choice and some written questions. Most of my exams look a lot like this. So anyone have suggestions of things to do when you've got a mixed format exam? What do you think you should do? Any suggestions? Yes.
I always go over the multiple choice first as kind of like a warm-up, and then I do the ones that I can do. Then I go to the written section, and then I go back and see if I remember something that I remembered in the written question to do in the multiple choice questions I didn't remember.
That's really good. That's a good strategy. Definitely. That's kind of what we're saying here. So scan the whole exam, like Ruth was just saying, right? Answer the easy multiple choice questions quickly. Be a little careful that it really is as easy as it says it is. Sometimes there are questions that look easy that aren't as easy as they look. Then spend some time on the written problems. It's important to spend a reasonable amount of time because they're typically worth a lot. Okay, look at the points the different problems are assigned. You can get partial credit on the longer problems, right? Which is not true for the multiple choice typically. And then start with the easier ones of the written problems, which might be the first 2 or 3 parts of a given written problem. Okay, maybe you can do parts A, B, and C, and you can't do D. So do A, B, and C, okay? And then maybe go back to multiple choice and then come back at the end, because it's true that you could learn things from the multiple choice that help you on the written and vice versa. So then do the time-consuming or difficult multiple choice questions last. And remember that you can always guess randomly if you run out of time. I hate it when I see people who leave bubbles blank. I'm like, at least guess. You have a 20% or maybe a 25% chance of getting it right if you just write A for the last one. Okay, it might be right. So it's a pity to throw away those points when, you know. And then the last thing is to keep your eye on the clock. Okay, make sure that you're spending your time wisely and that you don't run out of time when you were planning to go back. Like if you're struggling, you know, I would say struggle for a couple minutes and then move on and come back. Because remember, I was talking about this with one of my other classes, your brain will work on a problem subconsciously while you're doing other things. And so sometimes it will figure it out while you're doing something else.
And that's one of the values of distributed practice as well, because when you're not practicing, your brain can be working in the background.
Right. Yeah, good point. All right, so this is me again, I think, right?
Mm-hmm.
So strategies for written problems, specifically. So this is when you're writing out your answers. Please show all your work. Don't skip steps. Your goal is to make it so the TA can give you lots of partial credit, or whoever's marking, and that they understand what you're doing. All right. Write your work again clearly in a logical order. Don't forget to label the parts. This is part A, this is part B. Okay, make sure to label the parts. Double check your math. So do a calculation, write down the number. Do it again. If the number's different the second time, do it a third time. And whichever two agree, that's probably the answer. Okay, so that's a good idea for checking your math. Look at the final numerical answer and see if it makes sense. Okay, this works mostly for physics and chemistry problems where we're talking about the real world. Like make sure your object is not moving faster than the speed of light. Make sure that your cat is not like 2 nanometers in size or something. Like we're not gonna give you problems where the numbers are completely wrong like that. Okay, so double check that your answers make sense. Okay, and then also really, really important, don't forget units. When you're doing physics and chemistry, you're answering math. They care less about these things, physics and chemistry. We want to know the units. Okay.
You again.
All right. So word problem is the hardest kind of hard problem, right? Okay. So here's sort of a process for getting better at word problems. Practice the process for reading, pulling out the concepts. Because the whole idea is you read everything. So like it says here, read slowly and carefully and make sure you read the whole question before you go on. Don't assume that you know what it's asking. Read all the way through because there's also might be useful information in that first paragraph they give you. It's usually like 2 or 3 sentences at least. Okay, and practice, you know, the process of pulling out the concepts. Okay, write down your knowns, your unknowns, and what the question is asking you to find. It's typically going to ask you for one of those unknowns. Draw a labeled diagram. So incredibly useful for math, for physics, okay, for chemistry. Okay, not everything needs a diagram. Sometimes the diagram helps you solve the problem though, like right away. Then try to figure out which concepts this problem is dealing with. Then go to the formula sheet and find the formulas that apply to those concepts. Okay, is this a constant acceleration problem? Go look for your constant acceleration formula. Then you manipulate your formula and then put in the numbers. It's typically better to manipulate the formula first and then put in the numbers. Sometimes people like to do it the other way, put the numbers in and manipulate. I would say do whichever you're more comfortable with. I tend to do a little bit of each in class. So I would say whichever one you're happier with. Okay, and then again, show all your work, check your math. Okay, it's a pity to like get to the end and then make a math mistake. You won't lose a lot of points. If you make a math mistake early, it could make the rest of the problem harder, right? Because you might get an answer then it doesn't make sense for the rest. So definitely check your math early too. All right, so this is just an example of a word problem example from one of my classes. Okay, that might look like something you see in Physics 101 or Physics 120, where you've got a block resting on a table, it's connected to an empty bucket, and the whole idea is there's some friction here between the block and the table, and what you're gonna do is pour sand into the bucket until you've got enough sand to overcome what we call the static friction and cause the block to move, okay? And the question is how much sand do you have to add to get the block to move? So kind of a typical physics question, right? Okay, and so this is my solution to this problem, just to show you what a nice looking solution looks like. So diagram, knowns and unknowns, okay. Force or free body diagram, which is something we do in physics. Okay, 2 of them actually for each object. Okay, so that's our diagrams. Okay, and then we would go look for the formulas. We apply the formulas. Okay, we manipulate things around, put in numbers. Okay, I ask people to put boxes around answers to make it easy to find the answers, right? And then don't forget units on your answer. Okay, so that's the kind of thing you want to try. I know it's harder on the test, you're running out of time. Okay, but as best as you can. Okay, ask for extra paper if you need it. Okay, if you need extra paper, they can give you extra paper. All right, all right. Is this me or you again? Is this me?
That's you.
It's still me. Okay, so multiple choice exams. Okay, we got a little while left. All right. So I'm just going to go through this rather than ask you. We kind of talked about some of this before already. Highlight or underline what you're looking for. Look for the answer if you know it immediately. Some questions are typically easier than others. Basically, this is what you usually do for non-calculation questions. For calculation questions, sometimes it's enough to make an estimate of what the answer should be. Okay, and you can find it, at least you could rule out some of the options. And if you can rule out 2 of the options out of 4, then you have a 50-50 chance of getting it right. Right? So if you can rule some of them out, that's always good. Drawing a picture often helps. Okay, and then for the calculation of multiple choice questions, it's very similar to what we were just talking about. Find the concept, find the formula that goes with the concept. Basically, then solve for the answer before revealing the options. That's one way to do it. Or guess and check, uncover the options and see which ones are consistent with the given values, like you could back calculate as another possibility. And then double check, okay, once you solve it, that you're actually solving for the right thing. Okay, so those are sort of hints for our multiple choice questions.
And then you've got an example.
Right, and then this is just a couple of examples. We're running out of time, I know. The first one is a concept, no calculation. So this is going to be something either you know it or you don't. So if you think you know it, circle it, move on. If you don't, just put a question mark next to it, go away, come back. Maybe your brain will work on it and you'll figure it out later, or you'll get a hint. This one is a vector problem for all of you who love vectors. Okay, but the nice thing about this one is if you were to draw a picture, I think you could figure out which was the right answer without doing any math. If you were to just draw it, right? Draw basically the 3 different displacements in 3 different directions. Okay, you could probably figure out which one of those is the right answer. Okay, so that would be an example of that.
Finally, we're back to me, and there's not much left, but if you do have to leave, feel free. If you can stay, you can stay. So, you know, if you do get like so anxious that it's interfering with your performance on an exam, there are some things that you can do. I'm going to go through the grounding activity. I mean, you don't want to do anything that takes a long period of time. But, you know, if you have practiced meditation, if you've practiced breathing techniques, even a couple of deep full breaths can help. But I'm going to go through the grounding activity for you. So do it with me, please, if you can. Notice, and you don't have to say it, but in your head, notice 5 things that you can see. And the next one is notice 4 things that you can feel in your body. Three things that you can hear. Two things that you can smell. And notice the taste in your mouth, the one taste in your mouth. How do people feel at this point? Yeah. I mean, it can calm you down. Try it maybe when you're like anxious about something else outside of an exam situation. Yeah, and there's sites like if you Google, 5, 4, 3, 2, 1 exercise, you'll find the script for it. But it gets you back into your body. It gets you in touch with your senses, and there's nothing that could be more calming than getting into the present with your senses.
Seems like that would help you go to sleep too. I think that would be helpful.
Yeah. I mean, anything where you need to kind of relax your body.